Hello children, welcome to the class. Children, in the previous class we discussed remainder theorem and problems related to remainder theorem. Today we will discuss the factor theorem. So let's begin our video with factor theorem. Children, first write down the statement of factor theorem. If p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then the first condition x minus a is a factor of p of x if f of a is equals to 0, and the condition 2, p of a is equals to 0 if x minus a is a factor of p of x. So children, this is the statement of factor theorem. Children, I will repeat the statement once, follow it. If p of x is a polynomial of, this is OF of, that's all, here there is no double F, it is a single F. If p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then here there is a two conditions. The first condition, x minus a is a factor of p of x if p of a equals 0, and p of a equals 0 if x minus a is a factor of p of x. Children, once observe this statement, just read it yourself once again. What do you understand here? Observe the conditions carefully here. Here, x minus a is a factor of p of x when the remainder of p of x, means if we divide p of x with g of x, we get p of a is equals to 0. And observe the second statement, it is reverse statement of first statement. So here p of a equals 0 if x minus a is a factor of p of x. There is no much difference in these two statements, both are same, but here if x minus a is factor of p of x, then it should be p of a equals 0, and if p of a is equals to 0, then we can say that x minus a is a factor of p of x. So this is the statement of factor theorem. Let's see the proof of this theorem now. Proof. By using remainder theorem, we are going to prove this theorem. So first consider the remainder theorem. By remainder theorem, p of x equals x minus a into q of x plus p of a, where q of x is the quotient when p of x is divided by x minus a. That means x minus a is divisor. So this is the remainder theorem. I hope everyone know this. Now let's prove the first condition. If p of a equals 0, so put this condition in the remainder theorem, we get if p of a is 0, this term is 0, then we left out with p of x equals x minus a into q of x, which shows the x minus a is a factor of p of x. How? For this, let's see one simple example. Just recall division of whole numbers. Here we are going to divide 12 by 6. That means 12 is dividend and 6 is divisor. If we divide 12 with 6, we are going to divide by 2 times. So 6 2s are 12. So if we subtract, the remainder is 0. Then by using remainder theorem, we are going to write this division in the equation, that is here p of x is 12. So dividend is 12 equals, here divisor is 6 into quotient plus remainder. So here remainder is 0. That means we can say 2 and 6 are factors of 12. So we can say that 12 is a multiple of 6. So we can say that 6 is the factor of 2. Right, children? I hope everyone studied these steps in the early classes. So by using this concept, we are going to say that x minus a is the factor of p of x. Just observe this equation. We get same as this format. Here p of x is dividend and x minus a is divisor and q of x is a quotient. Here also observe 12 is a dividend, 6 is a divisor and 2 is the quotient. Right, children? So here x minus a is the factor of p of x. Here 6 is the factor of 12, or we can say that 12 is a multiple of 6. I hope everyone understood the proof of first condition here. Let's see proof of second condition now. Second condition says, since x minus a is a factor of p of x, such that p of x equals x minus a into g of x. We are just rewriting this condition in reverse way. First we are considering this statement, x minus a is a factor of p of x. Then we can say that p of x equals x minus a into g of x for some polynomial p of x. So for this condition we can write p of a equals, in the place of x just replace a, we get x minus a equals 0. So 0 into anything we get 0. That means p of a must be equal to 0. P of a is nothing but the remainder. So just go back to remainder theorem and we consider that p of a as a OR. Right, children? So this is the proof of factor theorem. I hope everyone understood. Here it is a simple theorem. Just practice twice, you will understand better. So let's see some examples related to this theorem. So this is the example. Check whether the polynomial q of t equals 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1. So children, this question I given in your home assignment in the previous class. So just verify your answer with this answer. Now we are going to solve this problem by using factor theorem. So here we need to check the given polynomial is a multiple of 2t plus 1. Okay, so let's see the solution here. To solve this problem, we need to find remainder for this dividend if we divide this polynomial by this divisor. So if the remainder is equals to 0, then we can say that this q of t is a multiple of 2t plus 1. I hope everyone understood. Write down in the sentence. Finding remainder when, so here q of t is a dividend, is divided by 2t plus 1. 2t plus 1 is the divisor. In the first step, we need to consider divisor equals to 0. Put divisor equals to 0, that means 2t plus 1 equals to 0. Now we need to solve for t. So 2t equals, we are shifting plus 1 to RHS, we get minus 1 here. So that 2t equals minus 1. So t equals minus 1 divided by 2. So this is the value of t. Next we need to put the value of t in this equation. So in the second step, q of t equals 4t square plus 4 q of t equals 4t cube plus 4t square minus t minus 1. Just putting the value of t in this equation, we get q of minus 1 by 2 equals 4 into 1 by 2 whole cube here, minus 1 by 2 whole cube plus 4 into minus 1 2 whole square minus of minus 1 by 2 into minus 1. So if we solve this equation, we get, here observe, minus 1 divided by 2 whole to the power of 3. That means we need to multiply minus 1 by 2 into minus 1 by 2 into minus 1 by 2. Right children? Here minus 1 by 2 into minus 1 by 2. Here minus into minus we get plus 1 by 4. If we multiply first two terms into minus 1 by 2 we remains here. So again plus into minus we get minus. So 1 by 4 into 1 by 2 we get 1 by 8. So here we written minus outside and 4 into 1 by 8 plus similarly multiply 1 by minus 1 by 2 two times we get plus 1 by 4 here. So we written plus 1 by 4 here and minus into minus 1 by 2 becomes plus 1 by 2 here and minus 1 we written as it is. Now just divide 4 ones are 4 twos are. We get 1 by 2 here minus 1 by 2. Here 4 into 4 and 4 cancels here. We remains 1 plus 1 by 2 minus 1 by 2. Here minus 1 by 2 plus 1 by 2 cancels and plus 1 minus 1 cancel. We remains with 0. That means remainder equals q of t of 1 minus 2 is equals to 0. Hence we can say that remainder is 0. 4t cube plus 4t square minus t minus 1 is the multiple of 2t plus 1. If we get 0 as a remainder, we can say that 2t plus 1 is also factor for this q of t, or we can say q of t is a multiple of 2t plus 1. I hope everyone understood this example. Before going to next example, write down some important note here. The first note is, if x plus a is a factor of f of x, then observe children here, x plus a, then f of minus a should be equal to 0. If we solve x plus a to x, we get, if we solve this expression to 0, we get x plus a is equals to 0. That means if we solve for x, we get x is equals to minus a. So now we are going to put this minus a in the given p of x. Then we get f of minus a equals 0. Right children? So here f of minus a equals to 0. Let's see second note here. If ax plus b is a factor of f of x means polynomial here, then f of minus b by a is equals to 0. Repeat the steps, just equate this expression to 0, then solve to x, we get x equals minus b by a. So we get finally remainder as p of f of minus b by a equals 0. So let's see the third note here. If ax minus b is a factor of f of x, then f of b by a equals to 0. So just equate this expression to 0 and find the value for x, we get b by a. So f of b by a is equals to 0. If we get the factor as ax minus b, then definitely f of b by a is equals to 0. And similarly, see the fourth note. If x minus a into x minus b is the factors of f of x, here we get two products, right children? So x minus a into x minus b is a factor of f of x. Then f of a equals 0 and f of b equals 0. Just solve this equation to 0. That means we get x minus a into x minus b equals to 0, right? So this means we are going to equate x minus a equals to 0 or x minus b equals to 0. If we put any of these value as a 0, we get entire thing is 0, because 0 into anything we get 0. So here x minus a equals 0 and x minus b equals 0. Now if you solve for x, we get x equals a and x equals b. So here f of a equals 0 and f of b equals 0. I hope everyone understood these four notes. So now let's move to another example. So this is another example. Check whether 7 plus 3x is a factor of 3x cube plus 7. I will repeat the question once again. Check whether 7 plus 3x is a factor of 3x cube plus 7x. Children, here we need to check 7 plus 3x is a factor of 3x cube plus 7. So children, here this is a divisor and this is the dividend. That means this is p of x and this is q of x. So this is the factor for this polynomial. And here observe one more thing. This is the cubic equation and this is the linear equation. So cubic equation becomes our dividend and linear equation become our divisor. So just keep this information in your mind. Now let's see the solution here. Now we are going to find the remainder when dividend is divided by divisor. Here the dividend is x cube plus 7x and divisor is 7 plus 3x. Right children? In the first step we are going to equate divisor equals 0. That means 7 plus 3x equals 0. Observe here, put divisor equals 0. That means 7 plus 3x equals 0. Now we need to solve for 3x. That means we need to solve for x. So write 3x as it is and shift plus 7 to RHS. We get minus 7 here and now solve for x. So x equals minus 7 by 3, right? In the next step we are going to put the value of x in the dividend. Let equate this dividend to p of x. P of x equals 3x cube plus 7x. Now put the value of x in this p of x. We get p of minus 7 by 3 equals 3 into minus 7 by 3 whole cube plus 7 into minus 7 by 3. In the next step we get minus 3 into, we just written whole cube as x cube divided by 3 cube. We know the identity of loss of exponents, that is a by b whole to the power of m. We can written as a to the power of m divided by b to the power of m, where b is not equal to 0. So we just used this identity here, and here 7 into minus 7 by 3. Just multiply 7 inside the bracket, we get minus 49 by 3. Right children? 7 into 7 we get 49. So we just multiplied plus 7 into minus 7, we get minus 49 here. So we written here. Now what is the value of 7 cube? That means 7 into 7 into 7. 7 sevens are 49. 49 into 7, we get the value 343. And 3 cube. 3 into 3 into 3. 3 3s are 9. 9 3s are 27. And children, observe here there is a 3. So we are just divide 1 3 to 1 3. We remains with 3 into 3, 9. So here we written 9. Now take LCM for 3 and 9. We get LCM as 9. I hope everyone know how to take LCM here. Now we are going to take LCM for 9 and 3. So just write down 9, 3, and we are going to divide these two numbers with lowest multiple, that is 3. If we divide 9 with 3, we get 3, and if we divide 3 with 3, we get 1. Again divide with 3, we remains with 1. Now multiply 3 into 3, we get 9. Right children? So 9 is the LCM for us. So now we need to multiply 9 with each term of these two. So 343 divided by 9 into 9, we get 343 as it is. So we written here 343 as it is. Now minus 49 divided by 3 into 9. Here we can divide 9 with 3, that is 3 ones are 3 threes are. Now we are going to multiply 49 into 3. We get minus 147. So in this way we are going to multiply LCM to each term. So finally we get minus 343 minus 149 divided by 9. So finally we get minus 590. That means we are going to add these two numbers, because minus 343 minus 447, we are written sign as it is, but we need to add here. So 347 plus 147, we get 590. Finally we remains with minus 590 divided by 9. Hence the remainder is not equal to 0. Then thus remainder p of minus 7 by 3 is equals to minus 590 divided by 9. So remainder is not a 0. Thus 7 plus 3x is not a factor of 3x cube plus 7. So this is our solution. I hope everyone understood the solution of this example. So now we are going to take another example. So this is the third example here. Examine whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6 and of 2x plus 4. Examine whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6 and of 2x plus 4. So children, here we need to find this is the dividend and this is the divisor. So first we need to check for this dividend, this divisor becomes factor or not. Again, for this becomes a dividend again. So for this polynomial also we need to find this divisor becomes factor or not. So let's see the solution here. Solution. First we need to check whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. So here the first we need to find remainder when x cube plus 3x square plus 5x plus 6 is the dividend here now and x plus 2 is the divisor. In the first step we need to equate divisor as 0. So put divisor equals 0, that means x plus 2 equals 0, and find for x, we get x equals minus 2. In the next step, we are going to equate the dividend as p of x, and putting the value x in the p of x, we get, let p of x equals x cube plus 3x square plus 5x plus 6. Putting x equals minus 2 in p of x, we get p of minus 2 equals minus 2 whole cube plus 3 minus 2 whole square plus 5 into minus 2 plus 6. Children, here minus 2 means minus 2 into minus 2 into minus 2. We need to multiply minus 2 3 times. So that we get minus 2 into minus 2 minus 4 into minus 2. So minus into minus, here we get plus, again plus into minus, we get minus, 4 into 2 we get minus 8. Similarly minus 2 into minus 2 we get plus 4. Here 5 into minus 2 we get minus 10. So in the next step we get minus 8 plus 12 minus 10 plus 6. Here minus 8 minus 10 we get minus 18, and similarly plus 12 plus 6 we get plus 18. So minus 18 plus 18 we get 0. Hence remainder equals p of minus 2 equals 0 here. So we can say that since remainder is 0, x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. I hope everyone understood here. Now you need to find checking whether x plus 2 is a factor of 2x plus 4. So this part for your homework. You need to solve this part in your homework book. So I hope everyone understood this solution. You need to solve remaining part in your homework book and take some more question for your home assignment. So this is today's home assignment and you need to submit in between 4 to 6. Okay children, practice the factor theorem 3 times in your homework book. I will repeat the question. Practice the factor theorem 3 times in your homework book and you need to submit your homework in between 4 to 6 p.m. Okay, children, I hope everyone understood today's class. So we will stop here. We will continue in the next class. Thank you all. Have a wonderful day.